Okay, this is a case study on code CAD versus traditional CAD. Full disclosure, I've already seen this video, so I could go over my own code CAD system and see what functionality is missing. So it's more of a fair comparison. And yeah, so I'm gonna go through this with you in real time, and I'm gonna recreate what this person is doing here. So here we go.
This video I'll make a simple gear. So let's start with the construction lines in this case. So go to the draw panel, expand it and select this construction line tool. Now click anywhere in the drawing area to start the construction line, and then click on the second point to make the horizontal and the second point here to make a vertical construction line. Now press enter to exit this command. Now go to the circle tool and click at the intersection point of these two construction lines and make a circle with diameter of 3.333 units. So let's type D, press enter, and then the diameter of 3.333 and press enter. Now we have the circle, but its size is very small, so I'll double click my middle mouse button to fit this circle in this screen, and here we have it. Now let's go to the circle again, click on the same center point, and this time make a circle with radius of 1.5 units. Now press enter again.
So that's a radius, so we're going to multiply it by 2, so we have the diameter.
Type
What
D for
diameters are generally
and enter a
easier,
diameter of
I find, in code CAD.
2.571 units and press enter. So here we have these 3 circles. Now let's go to the offset tool and select the offset distance of 0.047 units. Press enter and click on this line, click upwards, click on this line again and click downwards. Now press escape and press enter to repeat the offset tool and enter an offset distance of 0.130 units and press enter.
Okay.
Now once again click on this central line, click upwards and click on this line and click downwards. Okay, now we need to make another offset for this construction line. So I will go to the offset tool and select a distance of 0.107 units, press enter, click on this line, click on the left and then click on the right.
So he's going to do an intersection here.
Now we need to remove some extra geometries from our drawing. So I'll go to the trim tool, press enter and click on this part and then on this part here. Now let's remove this portion also, that's also not required, and let's erase the remaining part. And here we have it, this is small arc. So let's now first erase some extra geometries from the drawing and let's make multiple copies of this. For that I'll select the array tool. So go to the modify panel and select.
So what he's about to do here, if I remember right, is, and it's kind of convoluted, this pie slice is actually going to be the spacing, and it's not going to be the base of the gear tooth, which is what I thought when I was first watching this.
Select this polar array. Now click on this arc, press enter, and now click on the center of the circle, which is this point, and in the items select 18 as number of items. Okay, and also make sure that this associative option is unchecked. So in this case you can see that this associative option is not checked. Now close the array. Now go to this area of the drawing and select the 3-point arc tool. Now carefully click on,
and yeah, this is where you'll see
this point, the intersection point of
the spacings are actually
line
used
and the circle.
for the starting.
Then click on this point and then click on this point.
So we have to go back just so you understand what I'm doing here too. So I'm getting the intersection point of this, but you need to imagine that instead of it being vertical, I put it sideways just because the math is easier. And I'm finding that point, and then I'm actually finding the angle using ATAN2. It's a very common math function in engineering or anything really, to find the angle from a point on a circle. And then because we want to be a pie slice, we need to multiply it by 2. And then after that, he repeats it 18 times.
Array. Now
So,
click on this arc, press
we'll do
enter,
cells.
and now click on the center of the circle, which is this point. Then click on this.
Go a bit further here. Okay, here. So we actually need to calculate the spacing in between these 18 repetitions. So the way we do that is we simply call distribute radial. So distribute radial, and we put in our angle, which is A1, and the number of cells. And we need to include it in here. Distribute radial. And that'll give us our spacing. And then he starts from the 90 degree and makes his way down to that little point there. So we have to do a start from 90 degrees. And we need to add up 1, 2, 3, 4 spacings. So spacings is equal to 4 times spacing. And then we also need to add up the number of cuts here, which is 1, 2, 3, 4.5. So I'll call them A1s. A1 times 4.5. I know it would be nicer if these were switched quickly, but I'm trying to move along here. And then we need to find that point down here, which is which will be our first point of our 3-point arc. Then we just use simple trigonometry for this one. Start, subtract the A1s plus the spacings. So we start there, subtract it down, and then multiply it by our by the inner circle. So we go from the unit circle out to the inner circle. They do the same thing here for the y. So that's done. Then we get the other 2 points, which is here. Zoom in here. There. So this is the second circle and the second offset line. This is the most outer of the first. So just do it again. Intersection line circle, 0 degrees. You can also just write 0 there, it's fine. Again, these are offsets, so there's no x offset. We always want to offset on the y for this example. So for the second one, I think it's the second offset line. And then it's the second circle diameter. And again, because it's a circle, there's 2 intersection points, so we always want the one in the positive space. This is the third one. 3, or sorry, I think it's the first, yeah, it's the first offset line that we did with the biggest circle. We go up here, the biggest was the 3, this is the middle, this is the smallest. And then simply get the radius of the 3-point. So the 3-point arc function
Arc tool.
finds a circle.
Now carefully line represent this point and then
so our 3-point arc function is going to find a circle that fits a circle, and it's going to return us the point where that circle should start, the origin, and its radius. So 3-point arc, we need to import it. 3-point arc. Oops. P1, P2, P3. Very simple. And then after this, we can start constructing our tooth. So I'll let him play in the background.
now we again need to clean
And
some
I'll
extra
just do this here.
geometries from the drawing. So firstly, I'll just remove all of these lines. These are not required. And now go to the trim tool, press enter, and click on this circle. And here we have it, the clean geometry. Now go to the fillet tool, select radius, and enter a radius of 0.062 units. Press enter. Now select this multiple option to repeat it for both of these sides. So I'll select this and this portion of the geometry and these 2 portions. Okay, now we again need to remove some extra geometry. So I'll select these 3 construction lines, remove them, and select all of these objects from here. Remove them as well. Now carefully remove this and this arc and erase them. Now we only have this single gear teeth, and we'll make multiple copies of this. For that I'll select it. Again I'll go to this polar array, select the center point, and in items enter 18. and press enter. And here we have it. Once again, make sure this associative option is unchecked and click on close array. And now we have our gear profile almost prepared, but we have these gaps to fill. And in order to fill this gap, we can use this blend curves tool. So select this tool and blend the gap between any of these two geometries. So I'll click on this part and then here on this part, and the gap has been blended with the help of a spline, but we don't want it as a spline, so we need to convert it into a polyline. For that, double click on the spline and from the command line select this convert to polyline option and press enter with the default value of 10 in the precision. And here we have it. Now this geometry is a polyline. Now once again go to this polar array option, select the polyline, press enter. Now go to the center here and in number of items enter 18 and press enter. And now you can clearly see that all the gaps are now filled. Once again, associative option should be unchecked and close the array. And now we have our gear almost prepared. Now we only need to make the internal profiles, and for that I'll select the circle tool. So select the circle tool, click on this center and make a circle with a diameter of 0.5 units. Now press enter again, click on the same center point and make a circle with radius of 0.5 units. Press enter, click on the same center point and make a circle with radius of 1 unit and press enter. Now we need to make a key way, and for that I'll select this rectangle tool and click anywhere in the drawing area. You can even click outside, so I'll click.
So I'm basically done here. There is a mess up somewhere. I think it has to do with the intersection lines here. But yeah, that's basically it right there. I feel like there's a division here that oh yes, right here. So if I do this, there we go. So we have his and we have ours, and I'm not going to bother with the inner circle, but that's it. And then from here we can also do some funky things like so that's a spur gear, and I learned that you could do different types of gears just by either twisting to do a helical gear or by tapering. I think it's called a bevel gear, then a minor gear. So bevel is going to be a spur with a taper XY along Z. Actually, this is a bit tricky, so I'm not going to do it for this. But let's just do twist. And it should give us, there you go. So this is a helical gear that we were able to, whoops, I'm on the axis, so yeah, very easy then to bring this even further. In other CAD systems you would do, I'm pretty sure it's like an extrude with a twist, but this is actually twisting the mathematical boundary of that shape. I would do the taper, but I forget the parameters off the top of my head and I want to keep this short. And yeah, that's it. Thanks.